Good afternoon. Welcome to this afternoon's part 2 of roadway drainage maintenance online. I'm Victoria Beal with the Ohio LTAP Center, and I am so pleased to be collaborating with my colleagues at the North Carolina LTAP Center, specifically their instructor Scott Tyson, who is going to be presenting this afternoon for you on roadway drainage. And I'm not going to take up much of your time here at the beginning. I just do want to mention that we have a handout for you with the slides from today in the handout pod. And then we also have a couple poll questions we'll be doing with you, three throughout the presentation today. And then last but not least, just to make sure that you know where the question box is, if you wouldn't mind dropping me a hi or hello in the question box, just so I know you're there and you found it. I appreciate that, because that is how we'd ask that if you have questions for the presenter, please go ahead and put them in, and then I'll read them off to him. So I believe that's all I have. So without further ado, I'll turn things over to Scott.
Victoria, thank you very much. Good afternoon and good morning, everyone that's on the call today. I appreciate you. If you were here on Tuesday, thank you for coming back and being a part of this. If you're new, I want to welcome you also. Just to give you a little bit of background about me, spent about 9 years with the Florida LTAP FDO team, Public Works in Florida, working on roadway problems, whether it be flagging, work zone, drainage, guardrail, some asphalt and concrete. So I touched a lot of different things. For today, we're going to go. If you want to go ahead and contact me, I'm going to give you my slide here. Go ahead and write that down if you would. Always easiest to email me. I'm happy to answer any questions that you have. If you need any documents or anything, Miss Victoria can certainly help you with that as well. Let's go ahead and start. I've got a couple of things that I want to talk about, and the first one's going to be a very brief overview, and those are wetlands, high quality waters, because these come into play when we're putting down our roadways and we're getting near those areas. We're going to talk very briefly about that, because that's an entire 6.5 hour teaching just on that, and probably more that we could spend. So we're just going to lightly touch on it. And then we're going to talk about some different planning ideas that we have: erosion control, when to seed, when to mulch. We're going to go through a little bit about that. And then we're going to launch into our ditches, and we're going to launch into our pipe. So that's kind of where I'm looking to go today. And we mentioned wetlands and high quality waters. When we talk about wetlands, high quality waters, depending on where you're at, you may have a different term for it, and that's perfectly okay. Typically, those types of areas are areas that are underwater. The land is covered for a certain number of days that prescribed. It may be different in your area or in your state. For the state of North Carolina, it's got to be a minimum of 15 days. And then that is considered a wetland or a high quality water. And the reason we call them high quality waters is because these areas are meant to be literally water filtration systems. So the junk that gets carried out there gets filtered. So what we are very careful to try and do is keep our roadway and any development away from these areas so that they're not going to be disturbed. And it's not only for the vegetation, you have different underwater plants, aquatic life that's involved. So we want to keep things as far away from those as possible. But again, that's an entirely teaching for another time. But I do want to touch on that. When you're designing and when you're having to maintain, be aware of the areas that you're in and the wetlands that may be affected based on what your work is doing or what other work has been done. I want to talk about erosion control quite a bit early on, and we can see the water's flowing on the roadway. It's coming down into this area. There's sediment on the project, but you can see it kind of drops off. It stalls right there. The sediment's not getting to where we want it to go, so we're having divots and we're having issues on the project. And in this case, they decided to set up a rock check dam so that they could move the sediment down as the water washed it down. And the reason we put rock up here is so that it will filter out either the sediment or the dirt or any impurities. And that way only the water, as you can see down there, needs to be draining into the inlet. But if you notice here to the left, we had a bit of a sediment control failure. And that water is not making it where it needs to go. It's actually coming down. We have an indentation here, and it's not going the way it needs to. We need to get this repaired as soon as possible so that the water filters through and that we don't have the sediment settling out so much. Take a look from this angle. You can see it a little bit better. Again, We had the failure here. The water's still going towards the inlet, but it's not flowing the way that we want. May need to have lowered that a little bit to get the water to flow over it, depending on what the hydrology studies turned out to be, how much runoff we were anticipating. So we want to make sure we get the water flowing where it is. We want to make sure the inlet stays cleaned out. We may use a mat or a silt fence or a rock check dam. Those are things that we have in our arsenal. You may have other items that you use. That would make it possible for us to catch this silt, catch the sediment before it goes where we do not want it to go. Here's another example of some silt that is settling out. It's never making its way to the rock check dam. It's going to stop and it's going to settle out right here, which is a problem because we're not getting the water off where we want it to go, which is ultimately over that rock check dam down into our inlet. So we want to come and make sure the sediment is flowing, the sediment rather is flowing properly. Again, we may use a silt fence as one possibility of addressing this issue. Perhaps we may use a sediment dam to hold those areas back. That's fine. That's a good idea. Depending on where you are, you may use wattles. Some love them, some hate them. Everyone has an opinion on them, but we can certainly use those as a way to keep the water flowing where it needs to, but keeping the sediment, but also keeping some of the debris out. And if you look over here at the inlet, that's pretty heavily covered. We need that back, get that cleaned out, because if the water gets there, it needs to be able to flow properly. We need to get that water away from the roadway as soon as possible, and that's going to slow up the flow. So make sure that that's cleaned out and make sure that it's clean and free of debris as well. We mentioned a rock check dam a couple of minutes ago, but it's important to note that if it's not needed anymore in that area, go ahead and remove that rock check dam from the area, because if you'll notice, there's a piece of guardrail up here. So that means there's an area that is warranted to have that protection for run off the road motorists or something that could be a fixed hazard object. By leaving a rock check dam there when it's not needed, we are still creating a fixed hazard object that needs to be removed. For example, if a vehicle goes off the road there, they're going to hit that particular area. So we want to get that out of there as soon as possible. Again, if it's not necessary or if it's not helping, go ahead and get those things out of the way to make that area a little bit cleaner run out for a vehicle should they go off the road. In terms of ditches, let's talk about what are the types. I also want to talk about how do we construct one, and then finally, how do we maintain one? Now, in general, ditches are used to collect and disperse surface water to a controlled manner as we can. We want to control where it goes and how it gets there. We also want to make sure we're getting the groundwater to go down as quickly as possible. We don't want water sitting in our ditches for long periods of time, because again, that's a health issue because it causes stagnation, it causes mosquitoes, it causes parasites and those things. But also it becomes a hazard. What if a vehicle goes off into the ditch and there's water? There could be other issues that are created by it. So we want to get that groundwater down as quickly as possible. In general, there are a couple types of ditches. The first one I want to talk about are side ditches. In other words, we're collecting the water from the roadway and we're keeping it from actually getting to the roadway. We want to discharge that runoff from the right of way. We want to get rid of it as soon as possible. We want to direct it out to more natural drainage systems. What does that mean? Well, if we can divert that water out to an area that is a high quality water or into a lateral ditch to keep the water away, that's what we want to do. Again, we want to keep water as far away from this area as possible. Here's an example of a lateral or a side ditch. And you can tell the water is flowing, but this time of year with the leaves on the ground, that becomes a very easy opportunity for our pipes to be clogged and for our ditches to become blocked. So we want to make sure we're keeping those as clean as possible so that water is able to flow through to the other side. Here's a lateral ditch on the outside. This is an excellent way to keep the water off the roadway. We're directing the water that way, and you can tell the distance from the edge of the travel lane to where this is. It's a good distance, keeps the water away, it keeps the habitat nourished, but also it allows the roadway to stay as functional as long as possible. Now, I want to take a moment and I want to invite you to comment with a chat function. Here's a side ditch, a lateral ditch that was put into place, and I want you to tell me What do you see in this picture? How functional is it, and what are we accomplishing? Do you see any design faults? There are difficulties to maintain. If you go ahead and weigh in on that on the chat, and then Ms. Victoria will read to me what you submitted.
Great. Yeah, definitely just put those in the question box where you told me hi earlier. And they're saying drive is blocked. Oh, let me go back up there. Sorry. Drive pipe is blocked, culvert clogged,
Mhm.
standing water. Pipe looks like it is too small. Invert of pipe is too high. Pipe clog,
Mhm.
not enough slope, clogged inlet and higher invert elevation. Clogged culvert, culvert too high, plugged tile. Invert should be lower. Looks like pipe is blocked. The cross drain is too high. Pipe is too high. Trash and debris. Culvert needs repair. Needs maintenance. Blocked inlet. Standing water only one side of the culvert. Crushed culvert. Inlets blocked by rubbish. Water looks stagnant.
Mhm.
Pipe clogged. Pipe blocked. Culvert clogged. Pipe needs to be lowered. And they just, a lot of people have
Sure.
this, a lot of the same thoughts here.
And if it's okay with everyone on the webinar today, I'm going to guesstimate that was about 20 to 25 different variations of what you saw, and all of them were absolutely issues that need to be addressed. And when we talk about maintenance, when we design something, we construct it, somebody's got to come behind and keep this thing maintained. And this is not really set up very well to be maintained by the maintenance unit. You're absolutely correct. That pipe is too high. It looks like it's been run over. And I get what they were trying to do. You wanted a little bit of a crossover there, I guess, for emergency vehicles, local law enforcement. But unfortunately, our experience has taught us it's not just the official vehicles that use that area. Often it's others, and oftentimes we end up getting our stuff damaged. But another note that was brought up, and I think is very valuable, is you see all the debris that is there. Even if the water were at the level of the pipe, that debris is going to block it. It's not going to cause the water to flow, and you'll notice it's not even going to the other side. Also, it's too high. The water's sitting there, and as best as I can tell, this is not a high quality area. This is not what we would consider a wetland. This is just water that's not drawing down quickly enough. We want to make sure when we put our pipes in, when we're doing our ditches, we're actually moving water along. We're getting it out of the way as soon as possible, because eventually the water will draw down, but we want that area as clean and flowing as we possibly can. When we talk about different types of ditches, here's one I want to just briefly mention, and that is a berm ditch. And as you can see on the schematic here, the water would flow to this point. But then what we're going to do is we're going to build up an area that is higher so that when the water hits that area, it does not flow over and go down into the roadway. If I were being honest with the participants today, I would say I actually built one of these on my property down in Florida because I lived a little bit below where my neighbor lived, and their water rushed down quite a bit. So I built a berm ditch. You know what? It doesn't always have to be around a roadway. It benefited me as a homeowner because I know that water's, as we talked about on Tuesday, water is going to flow downhill. We just can't prevent that. So what I can do is prevent the water coming onto my property, and we can prevent the water potentially of getting down to the roadway. Now, some water might make it over it, but that's okay because the goal is to reduce the volume of water that slope has to deal with, that slope has to carry. Again, here's an example of a berm ditch. If the water gets into this area, it's going to have to rain probably 40 days and 40 nights to get the water back up that area and onto the roadway. So that's why we put it, again, high enough that the water will not come over the top. Talk about outfall ditches for just a moment. We collect and disperse surface water from our lateral ditches and pipe culverts, and this is an important word I want you to remember throughout the day, in a controlled manner. If we do not control the flow of water, water is going to go where it wants, and it's going to go as fast as we can. So we put our ditches in place and we set up our drainage system to control water as best we can so it's not destructive. It brings life, but it can also be destructive as well. Here's a good example of an outfall ditch out this way. You can see the water is away from the roadway and it's flowing out into a vegetative area, more than likely to be considered a high quality water, a wetland. Where I originally came from in Florida, maybe we would use the term swamp. So that's a good example of the water never going to get near the roadway. It's going to stay pointed out towards that outfall ditch. When we have ditch construction, there are 4 different types that I want to talk about today. The very first one is parabolic. The second is trapezoidal. The third is a V ditch. And finally, we're going to talk about rectangular ditches as well. Typically, the grade of a roadside ditch is desirably to have a minimum slope of 1%. What we do not want to have happen is have ditches so deep that vehicles cannot have an opportunity to get themselves back onto the roadway should they run off the road in some form or fashion. If there's an immediate drop right there into a ditch, then that motor vehicle has no opportunity to make that correction. And we'll look at that here in a little bit. In terms of the four ditch shapes, here's a demonstration of what those are. We have the rounded bottom, and that's another way of saying parabolic. It's a very good engineering term, but you can just think rounded bottom. For trapezoidal, I like flat bottom just because it's simpler to follow and easier to understand. And obviously V ditches are exactly what they sound like, rectangular ditch in the very same way. And you can see on this presentation, truly the best ditch shapes are parabolic and trapezoidal. And I'd like to take a moment and I want to get feedback from you. Why do you think these two are better shapes than these two? What might be the differentials that you can see from the schematic? If you'll go ahead and weigh in, Victoria will let us know.
I sure will. Hold more water, more natural constructability. Hold more water, more area for water to infiltrate. Traps more water, easier to maintain. More surface water, higher capacity. Side slopes stable,
Sure.
easier to clean. They hold more storm drainage, better water flow, more area, able to disperse water with
Mhm.
wider area, more capacity, easy vehicle recovery, efficient, less velocity, spreads out water and doesn't concentrate the flow in the center. Soil is stable at angles, lower velocity, less erosion, less chance of settlement, earthen rather than paved.
And those are excellent answers. Thank you to everyone who participated. I really appreciate that. And you can see we move a lot more water here in this design than we can in these two. And someone made mention of they're easier to maintain. The larger they easier they are to maintain. If you've ever worked in drainage, you know for a fact that a good motor grader operator, they're weight in gold because when we're pulling these ditches or we're digging them out, it's very hard to see. And those with experience that can do this, they're not a so next motor grader operator, pat them on the back and say thank you for everything that you're doing if they're doing a good job because this is not easy work to do, but they are a lot easier to maintain if you have this size versus say a V ditch or a rectangular ditch. One of the other answers we received was it'll move storm water more quickly. Notice that if water builds up too much here, it doesn't too much go except back from where it's coming. And if that's the roadway area back here, then that water is not flowing where it needs to, then it's just going to back up.
Scott, you faded out
It's
for
going to
me.
create a hydroplane
Sorry about that. You
or
faded
worse.
out
So we
there
want to
for
make
a second.
sure that V ditches, if possible, are not the best selections. Rectangular, again, that backs up. It doesn't move. Oh, sure. So when you get to V ditches are a little more difficult to maintain. Rectangular ditches, again, those tend to back up. They don't move as much water through, which is the important factor in a drainage system, keeping water away from the roadway. But also we want to add to what we said on Tuesday, and that is not just keeping the water away from the roadway, but moving it away as quickly as possible. Here's an example of a rounded bottom ditch here. It's a nice, and notice it's not perfectly rounded. That's okay. But the design around it, notice it'll move a good deal of water through that pipe area right there. When we're putting our ditch together, it is important that the bottom of the ditch needs to be at 12 inches below the sub base. Notice it's not above the sub base because that would put the ditch up here, which means the water wouldn't go anywhere. We want to keep it at least 12 inches below the sub base. Again, we want to keep the water as far away from the pavement and the different drainage components underneath the pavement as much as possible. We want ditches to be safe, again, for an errant motorist who may run off the road. And in times past, we've always talked about, well, perhaps they're inebriated, they're on some substance. In some cases, we have so many distracted drivers on the road, we want to give them an opportunity to correct themselves, hopefully. Now, this is dependent upon your state and upon your specs and your design standards. But we have a couple of different ditch linings that we use. We use vegetative linings or natural soil linings. And in some areas, we'll use paved linings as well. And again, this is something you need to check with your local area. Based on the velocity and the amount of water that you're going to move through a ditch, not just at any given time, but when you're preparing for 1 year, 5 year, 10 year, 25, 50 year, 100-year storms. That's going to determine what kind of lining treatment you're going to put in your ditch. Typically from 0 to 1%, if that's the grade on a ditch, straw is acceptable. If you jump up in grade from 1 to 3%, maybe one of those erosion control mats that we've talked about the last 2 webinars. Grades 3 to 5%, you can put a synthetic roving in there, and anything that is above a 5% grade can be used for stone. Again, you want to check your local areas to make sure which type of lining, which type of treatment that you need to follow. Here's an example of vegetative lining. It looks really good. It looks like the water is going to go off the road into the ditch area. Also notice that that looks like that might be an opportunity for a motorist to correct a driving error if they should. Perhaps they're checking, driving on the road or getting a phone call and they ease over just a little bit. This is going to be helpful to a motorist, but it's also going to work in conjunction with our drainage components. We talk about paved lining. You can certainly pave the middle there and move the water through. Although one thing I would recommend is you look in that picture, you can see there's a lot of growth. There's a lot of grass growing through there. You want to come back, clean that out so the water doesn't have any blockages, that it can flow properly the way that it wants to. I want to show you this one as well. You can see the water flowing. And remember, again, it's about what is the velocity? How much water do you anticipate? Or more properly, how much water do you know when it falls there is going to have to be moved? A lot of times, uh, when people are teaching this class, they say, well, you have to do it exactly this way. Well, you know your areas better than I do. If you want to come down to North Carolina, I'm happy to show you the areas that I work in and tell you how we should do it. But I don't want to tell other states how to do it. You need to contact your local people, but also work with the people who have the knowledge base, who work there and live there every day. They're a huge resource of information. They'll be able to help you understand the velocity and the volume of water. In terms of ditch maintenance, please make your ditch compacted and rounded. And we'll talk about compaction towards the end of this presentation. Make sure the grade is the same on both sides. You don't want different grades going down that roadway. It creates a hazard, number one. Number two, it can also lead to liability if there's an issue. You want to make sure that your ditch lining is not eroding. For example, if we put straw as our ditch lining and water comes through and carries all that straw down to the pipe, then all of a sudden that pipe can be blocked, or it's going to carry that straw through the pipe and onto the other side. So we want to make sure we're not eroding away what we're using. If we are, we may need to change the ditch lining, or we may need to put back some of the areas that have eroded. We want to make sure if there's any vegetation issues that are taking place, let's go ahead and get those taken care of. Let's assist in the revegetation of those areas. It's important to note a ditch should carry water away without creating erosion problems. So this is part of our maintenance, maybe even a rainy day patrol to check and make sure that the ditch lining is staying where it's supposed to be, then we're not washing it away. Here's an example of some standing water on the pavement. And again, if you look at this area, you have a sort of a ditch area here, but it's not keeping the water back. There's so much of it, and the grade that it is, the water's coming over and it's sitting. And if you'll notice this area right here, and we talked about this at length on Tuesday, there's a drop off right there. And that open area, until it's filled, is going to collect with water. Water will fill that area, and you're going to end up with a situation like this. Now I want to show you a different picture. This is actually at a state fairgrounds. And if you'll notice, the parking area is completely underwater there. But notice how this line, how it comes out, shoots out onto the roadway because either the pipe is blocked or there may be no piping involved. So that water is going to go where it can. And in this case, it's out in the roadway. We see the cracks that are taking place in the roadway. We can see that down that area. So we want to make sure that we don't have water standing on the pavement. We want our ditches, we want our pipes moving that water away so as to make it simpler for our motorists to navigate roadways. And I'm certain that the problem persists where you are, as it does here where I am, but it does seem like motorists tend to drive a little bit faster when it's raining, so we want to make it as safe on them as possible. We will put riprap, we'll put rock in a lateral or an outfall ditch. And the reason we put that out there is, again, as the water comes through, we want it catching the silt and the sediment and the impurities. Let it pass the water on through the ditch, but let's keep that stuff behind so it's not getting out into the wetlands. It's not getting into the high quality areas. Now, having said that, I want to show you a couple of pictures, and this was some new construction at an interchange. And tell me what might be an issue here. Go ahead and weigh in the chat feature and tell me what you see.
Landslide, excess vegetation, no ditches,
Mhm,
paved channel
mhm.
blocked, slough off, grading issues, poorly maintained vegetation, slope failure, grass is a problem, looks like the landslide, vegetation growth, landslide,
Mhm.
clogged catch basin, no inlet at end of ditch, overgrown vegetation, embankment encroaching in ditch, maintenance issue, nowhere for water to go, vegetation blocks water flow, landslide, that same truck from an earlier slide.
You know
Oh,
what? He's causing trouble everywhere he goes. I'm not going to say
yeah,
who was driving it.
yes. Bridge apron maintenance needed, sediment buildup on side slope causing grass to grow and hold water, excess soil and vegetation. Okay.
And each of those things, Victoria, that you're bringing forward are all correct. Again, we have to maintain this. We have to cut it back. Otherwise, we're allowing water to infiltrate the roadway. And over time, and you can kind of see, you're going to start having cracking take place. It's very clear. But the problem is we're working with less people and less resources, but it is important to save us more money in the future. We have to make sure that our maintenance program is keeping this stuff cut back. But let me show you something else. This was a design at an interchange. It was turned over to the state, and you can very clearly see there's standing water in this median area. And I went back out to this area, and what I could not find was an inlet. I could not find where is that water supposed to flow. This probably is not the design that we need to be able to maintain. And what we want to make sure when there's construction projects being designed, that there are maintenance people who have a voice at the table, because we're the ones who are going to have to come behind and keep it going once it's been turned over to the state or to a local agency. So we have to make sure we can maintain it. So you want to make sure that we don't end up in a situation like this. Having said it a different way, here's some standing water. It's a lateral ditch, but it's so full, it's not flowing anywhere. So the water does what we said it will do. It flows back out onto the roadway. We need to get it in. We need to get that ditch cleaned out. We need to make sure the pipes are clean so we can get that water flowing again and get this taken care of. Now, these are some of the very basic maintenance issues. What tends to happen over time is if we don't address these issues, we end up in situations in terms of erosion, especially in a lateral ditch, that looks a little something like this, because there's so much water pouring through that it's now just pouring down and pooling. It's not going through the pipe. It's not moving, which is a problem. If water is sitting, if it's not moving, if it's not being drawn down, it's a health issue. It's also an issue for motorists, but it's also an issue for our drainage components because it will wear our drainage components down. So we want to make sure that we address these erosion problems as soon as we possibly can. Again, we talked about putting riprap in an outfall ditch. That works really, really well. That should protect and keep sediment and other things from getting into the area and causing a backup on that. Because if something does back up in a lateral ditch, it tends to look a little something like that. And we've all seen times driving down the road in our own personal time, water sitting on the side of the road or a lateral ditch that is blocked. That needs to be cleaned out. Well, how do we clean it out? Well, there are a couple of ways of doing it. You can use a vacuum truck. You can go in, especially if there are roots and things that have come through the pipe, you can certainly cut through those. Sometimes it's debris that needs to be taken out, but we need to make sure that we're on a regular schedule, checking our ditches and making sure they are free of debris. They are not being blocked. We've talked about lateral ditches, and the idea is keep the water away, okay, from the roadway. It runs lateral to the roadway, but it keeps water away. Here's an example of an area that does not have a lateral ditch. Okay, the water is just going to hit there, and it's just going to run down into the roadway. So over time, you're going to have roadway issues because there's nowhere for the water to go except down that angle, down that slope, and right into the roadway. And depending on how much water we're getting, it's not just that travel lane. It will expand across that double yellow line in the other travel lane as well. Some areas have chosen to use the half round concrete pipes. These are good if the water is going to flow down in it. It's going to handle a good velocity of water. But again, as we can see from this picture, you want to make sure we do not have these areas blocked. They need to be cleaned so the water can flow properly and gotten out of the way. Now that's in terms of ditches, but in terms of pipes, there are a couple ones we're going to look at today. The first one's going to be a corrugated steel pipe, a corrugated aluminum alloy. We're going to talk about some reinforced concrete, and finally the high density polyethylene plastic. It's important to note that every one of these pipes has real advantages to it, but it's also important to note sometimes they come with disadvantages. As a local agency, you need to decide which one has the most advantages and the least disadvantages, and that will work for your agency and the area that you're in. Make sure you make a good selection on that. We talk about steel pipe, in this case, corrugated steel. Notice that water will flow through it and out of it, but this is where we talked about scouring on our Tuesday webinar. And if you weren't on with it, that's fine, we'll catch you up. Scouring is when water, again, it's going to flow at a high rate of speed and pressure and volume, eventually starts wearing away that corrugated area. And what happens is that corrugated area allows the water to flow over it. It slows it down a little. Without it there, water has the potential to pool. In fact, we probably should cut this area back anyway so that the water can come back. So they will work. They have advantages. They're easy to get in, but sometimes they're a problem because they tend to suffer with scouring. If you're using the routed concrete pipe, if it's reinforced, you want to make sure when you put the two pieces together, as you can see here, that there are no cracks and no issues. Now, especially when working with these with heavy equipment, these things get banged, they get bumped, they get dropped, they get cracked, and all of a sudden we have a water infiltration issue in these. We want to be very, very careful with working with reinforced concrete. In terms of the high density polyethylene plastic, those are good. They have some durability to them. One thing to think about though is as we put these out and the sun beats down on them, they tend to dry out, they tend to crack. So that is one disadvantage that they have. You can see we put in the high density polyethylene plastic here at a driveway. That'll work pretty well. We use this here over near one of the colleges, and you can see there's not a lot of cover there. And so that would work. They rounded it off, they arched it a little bit there. You want to make sure that your pipe shapes and sizes are correct. Sometimes we'll use what are called arched pipes, and we'll show that here in just a little bit. But we use those when there's a limited cover or maybe there's a larger amount of water we got to get through those pipes. Sometimes arched pipes have an advantage over a more circular pipe. The other one, and I just want to take a moment on this because I think it's important, is to better accommodate fish movement. 30, 40 years ago, this is not something we would have talked about in a drainage course, but recognizing how important the environment is and how important it is that we keep it as pristine as possible and allow fish and other wildlife to have their proper movement to handle their area, their spot in the ecosystem. We want to make sure we don't catch fish that way. We want to make sure they can flow through our drainage system if they were to get involved or get entangled in that. The circular full round pipes, again, they can be very, very good. Just know that when you're putting these together, you're probably going to want to put a geotextile, some type of wrap in between that joint area when you're putting them together. Here's an example of some arch pipes, kind of pressed down so that they'll be able to move a little bit more water through than maybe the circular pipe. You want to make sure you meet your minimum size for driveway installations. And here's an example of what we said. There's not a lot of cover here, so you don't want to put a rounded pipe out there and extend that all the way there. We arched it and we took that area away. Again, water's going to flow very nicely through there, but there's not a ton of exposed pipe that could be hit if a vehicle goes off the roadway. And as we move into the latter part of the day, we're going to start talking about pipe and compaction when it comes to pipe. So I want to show this. This is a very challenging situation. We have two very large rounded concrete, reinforced concrete pipes. We have all this rock on top of it. And now I'm going to ask you to weigh in. What are some of the challenges with putting these two pipes out there? Do you think this is good compaction? How could we even possibly get it? Is there any danger of these moving or giving? Give me some feedback on this reinforced concrete,
Should have a head wall.
if you would.
Compacting between pipes is
Hmm.
difficult. Not compacted between,
Hmm.
difficult to compact between pipes. One pipe always seems to silt in. LMS would have been a better choice. There will be erosion control issues. Box culvert would be better. Be worried the rock may crack the pipe. Driving hazard. Need a head wall with a wing wall. Not much cover. Use elliptical. Twins don't flow well. Kids crawling in pipes. Question
Hmm.
about a head wall again. Okay.
And each one of those are very good points. This would not be the that I would want to have, because you can already see there's some erosion there, there's some give. It looks like they tried to cover it a little bit. However, if there's any give down here and that pipe moves or gives, it's going to get out of alignment. It's going to cause water not to flow properly. It is incredibly difficult to get compaction between these two pipes on any level, which means it may not be setting them on a solid foundation, wedging density as possible. You can also see this is an area that gets a little that clean at the least. But thank you for those responses. All of those are absolutely useful to this discussion. In terms of pipe installation, you need to make sure that you have the right length, that it's aligned properly, and that you've got the right grade on it. Make sure that before you go to put your pipe in, your trenching is done, that you've got a foundation and pipe bedding if necessary. And by that, we're actually going to cut out an area underneath the pipe where the pipe is going to lay and fit so it won't slip and won't move. Make sure we're assembling our pipe correctly. And as we saw in this picture, one of the toughest challenges, especially when we start talking about getting compaction underneath the haunches, is our backfill and our compaction. To the best of our ability, we want our pipes aligned so it follows the natural location of a stream. If the stream is flowing this way, we don't want our pipes running that way, again, because the natural flow of the water and the hydraulic system, we want it flowing with it, not against it. When we go to excavate, and again, this is not a trenching and shoring course, but I do want to touch on it just a little bit. Make sure that before you start excavating, what's there before you start trenching. Make sure as soon as you're done excavating the area that you start putting that pipe in as soon as possible. If you don't, what can happen is it can start to cave in. That's one issue. Another issue is when we leave stuff out overnight. We were all kids once. We like to go play in areas and things we should not be. And we've had sometimes around the country issues where children were getting into these areas, and in some case the soil caved in on them. And so we don't want that to happen. We want to close up everything as soon as possible. If you're going to be putting any or doing any excavation underneath the pavement, make sure you cut the pavement first so that everything is ready to get done as quickly as possible. Keep your materials well away from the trench. If you put your pipes right next to a trench, if any of that area gives way, that pipe is liable to roll down into that ditch, into that trench area. We do not want that to happen. And it's probably a good idea. Go ahead and use a trench box or to keep that soil back on either side so that our workers can be protected. And by all means, as soon as you're done, get that trench, get that excavation area closed as soon as possible. We talked about a bedding just a couple of slides ago, and a foundation. If you have a very stable, uniform bottom, you can just put a pipe right in there. You should be able to get compaction on either side, and that should hold pretty well. But if you've got a rocky area underneath it, it's not very stable. That rock tends to move a little bit. Chances are you're going to put about a 12-inch addition in there to kind of make it a little bit more solid, so it's not moving all over the place. As we all know, rock is not uniform, so it needs needs to be flat surfaced across there. If you have a soft bottom, you may want to build that up some more to make sure you get above that softness to get it a little more firm, a little more dense. And obviously, if you have a very wet area, a very boggy area, you want to build up at least 24 inches that up above that boggy area so that it's a safe, stable, and foundation. The last thing we want to do is spend all the trench these areas putting the pipe in, and then the pipe rolling or settling and not doing what we wanted to do because we didn't prepare the base and the foundation. And you'll remember we talked about on Tuesday, if you were here, everything starts with a good foundation. If it's not put on a good foundation, it's not going to last super long. It's going to cost us more money in the long run. When we talk about foundation and bedding, we talk about how do you get compaction up underneath what are called these haunches to make the bed firm to get there. It's very difficult to get compaction underneath there. I don't know about you, but I'm not able to get my mind down there. You could hand tamp to get a little bit of compaction there. We want to make sure that those pipes are in a firm bed. They're cradled in there nicely. Those areas you're not going to give way so that it holds very, very well. To that end, you might just want to build a cradle to hold it, if nothing else. You see, we built up this area, but then what you would do is you would carve out, you'd hewn out this area so the pipe can fit in evenly, and that way it'll hold. Because as we've stated a couple of times in this presentation, it's hard to get good compaction underneath the haunches. It's very difficult to do, uh, and use the cradle as an alternative. Here's a pipe that was put down. I'm not going to sign off on its foundation and the pipe bedding. You can see the pipe is exposed. It's not covered very well. There is some vegetation over it, so we need to come in and clean that up so that we keep that well. When we're putting our pipes together, we want to make sure that we don't handle things too roughly because again, that can cause cracking and that can cause issues. If we break something, if we crack something, then we have to replace it. And God forbid we put the pipe in anyway, go ahead and go through all the work because we're gonna have to tear it all out again. Now we're paying 2 to 3 times more than we had to originally. Go ahead and if you're using concrete pipe bells, go ahead and shape the bedding so that they're gonna fit and connect properly. When you're putting your pipes together, make sure there's no debris in between them when you're connecting them. Make sure you're using the same, the pipe corrugations from pipe to pipe. You're not using different size pipes. You're not using different types of pipes. Make sure they go together properly. You can use a gasket or a geotextile as a wrap in the joint to hold it tight. Now, what we want to do, and we're going to end today, is talking about backfill and compaction. Now, it's been estimated that poor compaction has led to more trouble with pipes than any other factors combined. Compaction, and this gets a little bit engineering, but trust me, it'll be okay. Compaction is the process of compressing a given volume of soil into a smaller volume. Um, what what does that mean? That sounds very difficult to understand. Well, let me show you a picture. Let me tell you what we're talking about here. Compaction in general is pushing everything tighter. For example, look at this top picture right here. See all the air voids, the loose areas between that soil or between that rock. So what's going to happen is when a vehicle drives over it, those particles get pushed down. And notice there's a lot of air gaps in between, which means you don't know how those soil areas are going to compact when you drive over it. It could give in certain places. If this were rock, you know the rock would give. You'd have divots. You might have holes form because you just don't know because it's not very tight. If you look at the bottom, we talked about compacted soil. You can see there are some air voids in there, but not as many as we had up here. It's tight, it's dense. What we've done is we forced the air that is trapped between those particles, we forced that out of the area. We made everything closer, which means when a tire runs over that, that's going to give a much stronger support. It's going to hold a whole lot better than if we had it something like this and it was just loose soil. So you want to make sure we get that compaction, we get it as dense. I think of it as making a cake. If you've ever had a cake that was really heavy, really dense, that's what we're looking for. We want our soil, our pavements, we want it all to get compacted and be very hot, get as much air out of there as we possibly can. In general, compaction is probably, if you look across the spectrum, the easiest, the simplest. It's going to save you the most money in trying to keep a road's life going. It's also going to help with how much load capacity it can carry on a daily basis, because again, it's so compact, it's so dense that hopefully that's going to hold a whole lot longer. It's going to allow less water to infiltrate as well. Compaction increases the material, it makes it more dense. It takes all these different pieces and smushes them together. It makes them tight. You can use rollers. There are other devices that are approved to get the air out of those areas. You want to force those particles as close together as you can, get it as dense as possible. What are some of the challenges to getting good compaction? Well, what kind of soil are we dealing with? What are the properties of it? Is it granular sand? Is it clay? What are some of the soil issues that we have? Here's an important one. What about moisture content? How much water is in the soil? Well, we need to know that to be able to get good compaction. We need to test that and check that. We want to make sure we're using proper equipment that's in good working or following proper compacting procedures. Make a note if there are any weird environmental conditions around you. What if there's rain taking place? What if it's a rainy season? All of those things can action in your work. And finally, if you're putting down layers and lifts, thicker you're putting those down, those can affect your compaction as well. Keep our pipes flowing and looking good. Obviously, the most important thing, inspect on a regular basis. You do not want erosion to take place. We want to prevent it as much as we can by staying on top of it, keeping things level as much as possible. If things are eroding, we need facing those areas. Go ahead and practice preventative maintenance. What that means is on rainy day patrols, or if you're driving down the road or you're covering an area, you can see there's a problem, get shoved into inlets and gutters where they don't belong. You want to make sure you're keeping those areas as clean as much as possible. You want to make sure scouring going on, that you address that and you get that pipe replaced as soon as possible. If anything's been crushed, or if there's any silt going into an inlet or outlet, you want to make sure that you address that as well. Now here's an example of a driveway pipe that is partially blocked. And what's important about this picture, if you'll notice, is that in the roadway or is that on a person's property? Which is a very important question, which is going to lead us into our last day on Tuesday, because we're going to spend a good amount of time talking about what is the local agency's responsibility and what is the homeowner's responsibility. Because here's the issue now. Because this driveway pipe is partially blocked, you can see the water is now flowing out into the roadway. We certainly can see there's some hydroplaning issues here. We can see that coming around that curve, you may not be able to recognize that there's water on that roadway until it's too late, especially if someone's driving too quickly or at too high a rate of speed. It's an issue for the motorists coming in and coming out. It's an issue for emergency vehicles that may be on a call. But again, and this goes back to what we talked about on Tuesday and we've covered on today, that water in the roadway over time is going to cause that roadway to erode. You can already see erosion taking place, not just from the soil, but it's going to cause cracks to begin to develop. The water eventually will work its way down into the subbase, into the subgrade. And we already saw that if we don't get good compaction, we're not going to have a good road. So if you start inserting water underneath that good compaction where the soil is, that water is going to start turning it muddy. It's going to start wearing that area away. And eventually you're going to have a depression over the roadway in addition to the cracks and the other issues that are taking place. And again, not only for the roadway, but on the sides as well. You can see that we need to pull back some of these shoulders so that the water will flow properly. And notice it's not just right here. There's water flowing issues up that road as well. So what we have here, this is just one symptom of a problem on this roadway. So having said all that, I have a couple of poll questions that we want to go over today just to kind of reinforce where we were. And Victoria, if you would go ahead and put up poll question 1, I would appreciate it.
Is that the which ditch design is best?
Yes. Yes, ma'am.
Okay, I'm launching it right now. So which ditch design is
Excellent.
best? Parabolic and trapezoidal, V and parabolic, trapezoidal and rectangular, rectangular and V. I read that question, I kind of felt like I was going back to geometry class. All those
You
different
know what? It
shapes.
makes me break out in the hives just thinking about it. Yes, ma'am.
Me too. So they're voting very quickly, which is great.
Cool.
All right.
Mhm.
We're almost up there to 80%. And I got to tell you, this has
I
been
like
just
that.
a great webinar series. We want to thank you so much for doing this.
Well,
Okay,
I appreciate the opportunity to get on and talk about this. Thank you.
we are 80%, so I closed it out and shared the results. The top choice was
Okay.
parabolic and trapezoidal at 88%. And then we had like
Mhm.
3% for V and parabolic, 6% for trapezoidal and rectangular, and 3 for rectangular and V. So I'll hide the question.
Sure. And it is parabolic and trapezoidal will always be the best choices. Now, for the individuals that referenced a V ditch and a rectangular ditch, one of the challenges is what happens if you have V ditches or rectangular ditches and there's just no money in the work plan to get out there and make those rounded bottom or flat bottom. Well, the answer to that question is you just have to keep the V ditches and the rectangular ditches maintained as best you can. There's not a one size fits all for that. In general, the flat bottom and the rounded bottom will be your best selections, but we all work in areas where things have been this way for a number of years and there's just not an opportunity to get those addressed. And now, if you would go ahead and launch poll question number 2 about good compaction, please.
You got it. I'm launching it right now. So I'll read it off to
Thank you.
everybody. Good compaction is achieved by using rollers or other approved devices, running over the area with my pickup truck, letting traffic push the area down, or compaction, who cares? Hopefully you were paying attention during this webinar. You don't pick that last option. So,
Well, I figure if you pick that, you're being funny, and we like some levity here. So, but
okay. I like the part about running over with your truck, though. That's something we do out here where I live.
well, where I started in public works, I may have done that more than once too. So,
Yeah.
who am I to say?
Yeah. All right, I'm going to close the poll up because we reached our percentage we like to have, and I'm sharing the results. 99% chose using rollers or other approved devices, and 1% said running over the area with my pickup truck. So I'll
And
hide
like
those
Victoria
results.
and I, sure, and like we were certainly when I started in transportation, sometimes if you don't know what to do, you do the best you can. But once you know, then we're accountable for that. And yes, absolutely, using your rollers or an approved device to get that compaction. I mean, it's at the point now, I don't know if everyone's familiar, you probably are, with what's called intelligent compaction. I can sit in my computer in my office and I can tell the rolling pattern, how well we're getting compaction in different areas of the road. I mean, it's gotten that far technologically. So you want to have compaction as much as possible using the best equipment that you can. And then finally, poll question number 3, if you would fire that up, Victoria,
Yep,
about
it's
pipe
there.
maintenance.
Got it
Cool.
up. So pipe maintenance includes inspection on a regular basis, erosion prevention, practicing preventative maintenance, or all of the above. So they're voting quick on this one too. All right, we're up there already. Good job, guys.
Wow. Okay.
All
Excellent.
right, and the results are that everybody chose all of the above, 100%. So I'll hide that poll.
Now, my personality is everybody votes 100%. I tend to run the other way to whatever the opposite was. But in this case, you're absolutely right. All of those things are important to making sure your pipes are maintained properly. We're inspecting them, we're doing preventative maintenance, and we're making sure that erosion is not causing our pipes to fail or any part of our drainage system to have a compliance issue or to not be able to move the levels of water that we have, depending on where you are and how much rain you have or the wetland areas. Oftentimes there's a lot of water being moved in a very short period of time. So just remember, as we're selecting our pipes and we're doing our ditches, we want to pick the ones that are going to move the water through as quickly as possible, but also drive those on a regular basis and just make sure those are being maintained. There's not debris, there's not overgrowth from vegetation. We don't have kids playing in things sometimes, which does tend to happen as well. So that would be my last comment on that. And with that, we have about 5 minutes left, which was the goal. Are there any questions? Anything anyone wants to ask?
I've got the
Feel free.
question pod open and waiting to read off anything that anyone would like to submit. All right, well, nothing so far. So if it's coming in, it's going to be a long question.
Okay,
So,
well, we do short and long. That's fine.
yep, somebody did put in, says, this is great info. Thank you so much.
Well, I appreciate your kind comments and
Yep.
feedback. Again, we'll be back here on Tuesday to
Yes,
do a little bit more hands-on, how we're actually going to apply some of the stuff we've talked about on Tuesday and today. So I look forward to doing that with everyone.
wonderful. All right, I do have a question for you. It says, is
Okay.
there a problem with side slopes of parabolic ditches becoming too steep, and how do you prevent that?
Okay. So if I understand the question, you've got the parabolic, you've got the rounded bottom, and you're asking, can you make the sides too steep? And how do we prevent that from happening? Is
Yes.
that the question? Okay. All right. Well, initially, yes, there is a problem if you make them too steep because if a vehicle goes off the road, it's a rolling hazard. So it can become too steep. So at the original point of construction, or you want to make sure that the slope is correct from that point on, and as the ditch is maintained, you want to make sure that you're not adding any additional slope to those sides. You want to make sure you're keeping it as close to the original design as possible. Now, that's not always possible, but that's your goal. Keep it as close to the original as you can. Keep a maintenance program that is constant on it. The longer you wait to maintain or go out and fix something, the worse it's going to be, the harder it's going to be. And in some cases, at that point, we can't get back what we originally had anyway. So my recommendation would be from the time it's cut, just make sure you have a steady maintenance plan of keeping those slopes cut at the same slope.
Okay, I've got three more questions for you here, and that'll about take us to the top of the hour. So, next one is, how do you balance a
All right.
vegetated biofilter versus a roadside ditch
Hmm.
with getting the water away quickly?
And depending on where you are, depends on some of the environmental restrictions that you're going to have. Um, that is something that has to be dealt with at each local agencies at the base of where you are. Because here's the problem: I want to get that water off the road as quickly as possible, but I'm also dealing with vegetation. We don't want to mess that up. Tends to be a bit of a political issue as well, depending on what are some of the requirements that your local area has for how we're able to engage the vegetative lining, the vegetative area that you're talking about. All I can recommend to you is what we've done in the past, and that has been as transparent as we could with not only my leadership, but with the city or county that I was working in, and with the people, and say, listen, we have to do this to keep the water flowing. Yes, it may mess up some of the vegetative lining or the vegetative area, but this is going to be better than having to come in and spend 3 or 4 times on the roadway what we would normally have to spend. So sometimes there has to be some give and take there. Um,
All right, next question. Is there a formula for how tight the compacted soil needs to be?
there is not a formula that you need to adhere to. Now, there may be some standard specs that may address that in your area, or you may have some design standards on that. But no, there's not a national um, compaction spec necessarily, or what the percentage needs to be.
Okay, and the next one kind of came in three parts. It says, what happens if you can't achieve a 1.5, or excuse me, a 1% slope on ditch? What would you
Hmm.
do?
Call in sick the next day. No, that's a great question because one of the slides I did not use today. It is not a 1% slope, and it slopes down very sharply. And if any vehicle goes off the roadway there, it's not recovering. It's going nose down. There's just no other way to do it. And I'll be honest with you, that area is not going to get changed anytime soon unless there's an issue there that causes a different decision to be made. If you can't get the slope, you can't get the slope. I mean, we only have to work with what God gave us. So do the best that you can, but in some areas, you're not going to be able to get that 1% or that 1.5%. It's just not possible without redesigning the drainage system and redesigning the roadway. And if you have the funding to do that, by all means, do it. But my experience is we oftentimes just didn't have the money. We just had to work with what was already there.
Perfect. Takes us right to 3 o'clock. So thank you so much for all your time and all the work that's gone into this. We're looking forward to wrapping things up on Tuesday. And we also want to thank the North Carolina LTAP Center and their director, James Martin, for approving Scott to be the presenter for this webinar. I hope everyone has a great rest of your afternoon, and hopefully we'll see you on part 3 on Tuesday. Thank you.